Subchapter 1.4, single and double subscript notation. So what is single subscript? So single subscript notation VA, for example, specifies the voltage at point A with respect to the ground or 0 volt. All right. So this is, for example, so we have at point A or at node A. So the potential over here, the voltage potential over here is so called VA. So it's not clear, it is unseen. So let me write again for you. So this is VA, all right, positive and negative. Okay, at node A. So similarly at node B, at this point, okay, we have VB, which is the potential between point B down to with respect to ground or 0 volt over here. Okay, this is also 0 volt. This is actually connected each other, all right, because we have the same symbol over here, meaning the ground level. So this is equal to 0 volt. So this is actually equal or being connected. VB. So the notation of VB again refer to or specify the voltage at point B, okay, with respect to the ground. All right. Then so double subscript for voltage. Okay. So system of notation indicates the polarity of a voltage. Okay. Voltage across variable and exists between 2 points. So this is the keyword, between 2 points. So previously we have voltage across 1 point to the down to the ground, but this time around we have 2 points. So VAB, for example, so is the voltage at point A with respect to point B, between these two. All right, so we have VAB, okay, is actually a voltage point A with respect to point B. Okay, so this is how we notify the double subscript of point A and point B in terms of voltage. So VAB, okay, so this is direction, right, negative to positive for V, right. So similarly, if we refer to I, current, okay, so the first letter of the current subscript indicates, or the current subscript indicates where the current is coming from, okay, and the second indicates where it is going, the destination, for example. Okay, see, this is the origin of the position, okay, point A, right. So this is this node is actually point B, this is the destination. Okay, so this is again the origin, so where the current is coming from. Okay, the arrow or the direction is where current leaving A is actually heading to B, the destination of this particular current. So IAB is the current flowing from point A to point B. So this is a very direct notation. So we have A to B, so current from point A, okay, flowing to point B, okay, IAB. So VAB is in opposite direction. All right, so just what we have seen earlier. So this is VAB. So we see the different or the opposite direction compared to IAB. Okay, so this is V again. If I can write for you, so this is VAB. So these two are opposite, unequal. It's not equal, unequal. Then, okay, notation in three-phase system. So what about the three-phase system? So just now we have seen the simple system pertaining to the single or single notation as well as double notation. And this time around, so we will see what happened in three-phase system. Okay, So these two sets of voltage currents are interested, which are known as phase and line voltage. So basically we have V line, so we have V phase, as well as I line and I phase. So we have these two sets of voltage or two sets of currents. Okay? Then by convention, line and phase voltage are identified using sense arrows and double subscript notation. Double subscript notation, just like we have earlier, A to B, for example. All right. So the sense arrow, so this is the symbol, all right, of arrow. This is the simple example. So we have node A over here, sorry, not N over here. So to node R, all right. So the notation of V, okay, is VRN, okay. So this is the notation, okay. VRN with its arrow, okay. So for direction or arrow direction for voltage is always from negative, all right, to positive. Okay. So similarly for the second phase, Y, all right. So the direction of arrow for V is from negative to positive. All right. So it starts from N, okay, to Y. But when it comes to notation, so you see the difference. So we have VYN over here. Okay, YN. All right. So for V, the notation starts from the Y, for example. This is the destination of the or arrow or the V. So N is where it comes from. Okay. Again, similarly for the third phase, so we have VBN, negative, positive of the terminal. Negative, positive of the terminal. So we have this direction, and then we have VBN. So again, where the arrow is heading, the head of this arrow is heading B. So we start with B when we come to the notation. Okay, VBN. All right. So this is the head of the arrow, and this is basically the back of the arrow, something like this. Okay, B and N. All right. Okay, phase voltage, we do have VRN, okay, VYN, and VBN. Everything connected to N. All right, so everything connected to N, B to N. So we have V phase of BN for the notation. So R to N. So this is another V phase of phase voltage. Notation is Rn, all right, Rn. So Y to N for the last phase. This is another V phase, namely VY, VYN. Everything connected to N. Phase is known as every phase voltage. All right. So what about this one? Okay, just appear over here, VRY. So this is VYB, and the last one is VBR. So these are all known as line voltage. Okay, so when no N is connected, you can see it is notified by line R and line Y, and line B, and line R. All right. So B to R, again, the location where the location or the position of arrow, the head of this arrow, okay, it is where we should start writing the notation. Okay, B to, and then this is the, what I call it, the back of the arrow. So this is R. So V, B, okay, R. Similarly, so this is again, if I can draw the arrow, so the head over here, so it's coming to R. It's going to R, so you start with R notation. Okay, V, R. This is line Y, so we have VRY. Similarly for here, so we have from B to Y, so we call this, look at the arrow over here, the head over here, so it is heading to Y, so we start to write Y first, followed by B. So BY for the third phase. Okay. So what about what about current? So we have phase line current. So this is equal due to Y connection or Y configuration where a line equal to I phase. Okay. That's why it is simply written here, phase or line current, okay, represented by notation of IR, RY, and RB. So red, yellow, and blue. So problem number 1, okay, based on figure below, show and draw. So you must show, you must write, you must draw the subscript notation of phase and line voltages, phase and line current. So solution, again, voltage from negative to positive, okay, but we come to notation, again the head of the arrow is heading to R, so we start with R, and the origin is Y, where the arrow is coming from is Y actually, so we followed by Y, so this is VRY. Okay, what about the second phase? Yes, similarly, so the direction from negative to positive of the terminal. So we do have over here Y is the destination. Okay, we start with Y and followed by V for the phase voltage. And then VRB again, this is for the third one. So this is the destination. So this is where it is coming from. So we do have VB, VBR, and then the direction of arrow is always negative to positive. All right, this is for voltage, particularly for V and V and V. For delta connection, so VL equal to V phase. So for delta connection, so VL equal to V phase. So VRY, VVR, and VIYB over here, these three are actually V line and also V phase. Okay. But for IR, okay, IY, and IB, okay, this is a line current. Oh, sorry, this is for line current. This is another line current. This is another line current. Three different line currents where I line is equal to square root 3 I. Okay, this is for star connection. So for data, I have shown earlier in the previous slide, so you may refer back to last slide. So summary, single phase power system is one where there is no one AC voltage source, one source voltage waveform. So there is only one, sorry, there is only one AC voltage. The source of voltage, okay, is one. Okay. So split phase power system is one where there are two voltage sources, 100 degree phase shifted. So this is what we have seen in the beginning of this study or the beginning of the topic. So powering two series connected loads. So there are actually two voltage sources with 180 degree phase shifted, okay, from one to another. And then the advantage of this is the ability to have lower conductor currents while maintaining low load voltage for safety reasons. So we come to the conductor current, it is lower, and at the same time while maintaining low load voltage. Okay. So what about the polyphase power system? So it uses multiple voltage sources at different phase angle from each other. Many phases of voltage waveform at work. So we have seen just now the three phase, for example. So we have seen how it is being connected into N for Y configuration. So it may produce or may generate phase voltage, and it may also convert it to line voltage. Okay, and also we do have the the data, so we can actually convert the current, the voltage, the phase current to the line current, for example. Okay, but we come to V, it is equal. So polyphase power system can deliver more power. Okay, one of the prominent advantage at less voltage with similar gauge conductors than single or split phase system. So more power, uh, high power, but less voltage. Okay, so smaller gauge conductor, okay, than single system or single phase system. All right. So we have come to the end of first topic, and see you when we come to second topic number 2.